everyone, welcome to SWAYAM course on image processing using Python. My name is Bharti Patel, Assistant Professor, Computer Science and Engineering Department, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today's topic is applying image smoothing and sharpening techniques. So let's begin with the detailed description of today's lecture. So image smoothing and sharpening are image processing techniques used to enhance the visual quality of images. Smoothing techniques reduce noise and blur in images, while sharpening techniques enhance edge details and increase image clarity. In this class, we will explore various methods of applying image smoothing and sharpening techniques. Image smoothing techniques like Gaussian smoothing. In this, a commonly used technique that is applies a Gaussian filter to blur images, that reducing high frequency noise. Gaussian smoothing is based on convolving the image with a Gaussian kernel, which is a weighted average of neighboring pixels. The weights are higher at the center and decrease towards the edges, creating a blur effect. Here is an example of Gaussian smoothing which is applied to an image. First of all, we have to insert the image and we have to compare the original image and the smooth image side by side. In median filter, we have to replace each pixel with the median values of its neighboring pixels, effectively reducing salt and pepper noise. In median filtering, in which we have to create a non-linear technique that sorts the pixel values in a neighborhood and replaces the central pixel with the median value. So here is an example of median filtering applied to an image. For that, we have to insert the image of original image and median filter image side by side. In bilateral filtering, we have to preserve, or we can say it preserves edges while smoothing by considering both spatial and intensity differences. In bilateral filtering, it takes into account the spatial distance and intensity difference between pixels to determine the weights for filtering. Weights are very mandatory to take for the filtering. For this technique that preserves edges by smoothing pixels with similar intensities, it means the image is having the same intensity while maintaining sharpness at edges. So here is an example of bilateral filtering applied to an image. For that, insert the image of original image and bilaterally filtered image side by side. So what is image sharpening techniques? First is unsharp masking. It is a popular technique that enhances image details by subtracting a blurred version of the image from the original. In unsharp masking involves that creating a blurred version of the original image, that subtracting it from the original to obtain the high frequency components and then adding them back to the original image. This technique enhances edge details and increases image sharpness. So here is an example of unsharp masking applied to an image. First of all, we have to insert image of original image and sharpened image using unsharp masking side by side. In high pass filtering, that emphasizes high frequency components in an image and effectively enhancing edges and fine details. In high pass filtering, it allows high frequency components, which is called edges and details, to pass through while attenuating low frequency components, or we can say smooth regions. So it is achieved by subtracting a low pass filter version of the image from the original image. So here is an example of high pass filter applied to an image. For that, we have to insert the image of original image and sharpened image using high pass filtered side by side. Second type, that is called Laplacian sharpening. It applies a Laplacian filter to highlight area of rapid intensity change, thereby increasing image contrast. In Laplacian filter, it used to detect edges by computing the second derivative of the image intensity. By adding the Laplacian filtered image to the original image, the edges are emphasized, resulting in increased image contrast and sharpness. So, here is an example of Laplacian sharpening applied to an image. In this, we have to insert the image of original image and sharpened image using Laplacian sharpening side by side. So, example of image smoothing and sharpening is here. Before and after comparison of images which are demonstrating the effect of various techniques. In example 1, Gaussian smoothing, it is basically for removing noise while preserving overall image structure, or we can say the structure of whole images with all the pixels. In this, we have to insert the image of original image and smoothened image while Gaussian smoothing side. So, in image smoothing techniques, that is called Gaussian smoothing, we have mainly use a commonly used technique, that is applies a Gaussian filter to blur images. It reduces the high frequency noises. So, here is the code. In this code, we applied that smoothing technique in which we have to import the library functions, that is called CV2. Then we have to load the image and we have to read the image by image read. Like we have some image with format of JPG, you can use any other format also like PNG or as you want to use. So, we are using JPG image format for this image read. Then apply Gaussian smoothing blurred image. In this, we are using the function of Gaussian blur with the image values like 5, 5 and 0. So, after applying Gaussian smoothing blurred image, we have to display the original and smoothened image. For that, we are using image show, that is the keyword to show the original image and the Gaussian smoothing blurred image. After that, we have to display the whole window and we have to calculate all the values of the images. Then in median filtering, we have to analyze that what is the work of that median filtering. It replaces each pixel with the median value of its neighboring pixels, like effectively reducing salt and pepper noise, which is very common noise in the image, and we have to reduce this noise because it is very important to reduce for image quality. So, according to Python code, now we are going to understand how it works. So, first of all we have to import the library, import CV2 or we can say NumPy. After that, load the image. Again we have to read the image with whatever suitable format you want to use, either JPG or PNG or MPG. So, we have to read the image, then apply median filtering. In this filtering, we have to use the function as median blur with the image and the value for noise should be removed. Then display the original and medial filtered image, and we have to show the image which is initially original image. After that, we have to show the image by using image show, which is median filtered image or we can say median filtered image improved. So, in bilateral filtering, it preserves edges while smoothing by considering both spatial and intensity differences. Again, we can understand this filtering method by Python code. In Python code, we need to import the library which is called import CV2. Then we have to load the image, that is our input image. By using image read, IMRED, image read, we can read the image. After that, we have to apply bilateral filtering or we can save the filtered image. But before that, we have to give the values like 9, 75 and 75. This is the color spaces values. We can choose another values also according to the image. So, we have to display the original and bilateral filtered image and we can show by image show key to our original image, and bilateral filtered image, which is called bilateral filtered image overall. So, image sharpening techniques, basically it provides various methods like unsharp masking, as we discussed previously, a popular technique that enhances image details by subtracting a blurred version of the image from the original. For that, again we are using Python code through which we can understand how it works. You can use this code onto your system and apply it and get the output. For that, we have to import the libraries as import cv2, then import numpy as np. Again we have to load the image, and we can say that we have to use image read, which is reading the image or fetching the image from particular source to get executed. After that, we have to convert that image to grayscale image. We need to convert by CVT color function, which already we have learned in the previous lecture, which is called understanding of image color spaces. In that we use that CVT color conversion function. After that, apply Gaussian smoothing to create a blurred version of the image, and we can get that blurred image by using this CV2 Gaussian blur function. In this we have grayscale image with the specified or respective values. So, perform unsharp masking sharpened image. In that we have to add the weight value to adjust or to map that particular gray image with that image, and we have to justify that which one is the grayscale image and which is the blurred image with this particular values. So, we have to display that original and sharpened image. For that, we have to use image show key, that is the word, to show the original image or grayscale image, and image show which is using to display that unsharp masking or sharpened image. So, this is the overall image which is converted into grayscale to perform that particular task. In high pass filtering, it emphasizes high frequency components in an image, effectively enhancing edges and fine details. We can understand this code using Python, how it implements. Like we have to import the libraries. First of all, we have to import cv2, then import numpy as np. After that, we have to load the image, or we can fetch the image by some source using image read. After that, we have to convert that image to grayscale image, again using CVT color function. This is used to convert a particular image into grayscale image. Here we are using BGR image to grayscale image. You can use any other color space like RGB image to grayscale image. So, apply Gaussian smoothing to create a blurred version of the image. Here we are creating blurred image with that Gaussian blur function. In this function, we have to give that gray image value and the gray image itself. After that, perform high pass filtering by subtracting the blurred image, and we can get the subtracted image with the blurred image. So, display the original and high pass filtered image. By using image show, we can show the original image or grayscale image, we can show the high pass filtered image and the overall high pass filtered image complete. So, sharpening basically applies a Laplacian filter to highlight area of rapid intensity change, thereby increasing image contrast. We can understand this using Python code. Here we have Python code, you have to implement on your system and you can check. So, for this we have to get the libraries, that is called import cv2, or we can say import numpy as np. Then we have to load the image. Again we have to fetch the image and using that keyword image read and with any format. So, we have to convert that image to grayscale. Again CVT color function is using. Here we are using image which is BGR and we are converting it to grayscale. After that, we have to apply Laplacian filter, which filter gives that grayscale image with that particular value. So, we have to get that grayscale image using this function. After that, we have to normalize the output to make it suitable for display Laplacian image. We need to normalize that image with sufficient value. Now, we are using that value as none, 0 and 255 with that particular image. So, we have to display the original and sharpened image by using image show key. Image show key will define which one is the original image, which is grayscale image, which is Laplacian filtered image, and the overall complete picture. So, understanding kernel size and parameters, this is another factor which we have to learn. It is very important to learn because it gives the understanding of the parameters which are going to be used while filtering. So, kernel size and parameter values play a crucial role in image smoothing and sharpening techniques. Let us explore their significance. In kernel size in smoothing techniques, basically the kernel size determines the neighborhood size used for filtering in smoothing techniques. That neighborhood size is very important to get that pixel value, or the larger kernel size includes more neighboring pixels in the filtering process. So, we can learn it by some techniques like in Gaussian smoothing. Again, we have some Python code through which we can understand how it works. So, in Python code, we have to import the library. We are using import CV2. Then we have to load the image. By loading this image, or we can say the image type whatever you want to choose like JPG, PNG, we are using JPG here. So, we have to read that image. We have to apply Gaussian smoothing with different kernel size. We have taken here image with particular size and we have calculated the Gaussian blur image with some particular size. So, we have to display the original and the blurred images by using image show. Through image show key, we can justify that which is the original image and which is the blurred image with particular size. Like here the blurred image which is showing 3 cross 3, that is the pixel value, and blurred image that is showing 9 cross 9, that is also another blurred image with the modified pixel value or the size of that particular image. So, bilateral filtering, we can apply the same method with bilateral filtering, and again you can use this Python code to check whether it is working or not on your system. So, first of all we have to import the library CV2. Again we have to load the images like image read or with particular format. Then we have to apply bilateral filtering with different kernel sizes. Again here we are taking the filter size. Before that we have to justify that image size and we have to filter that image with particular justified size. Then we have to display the original and filtered images by image show, which is particular showing the original image or the filtered image of our respective sizes. So, next is understanding of sharpening parameters. Again we are discussing about the parameters. So, in sharpening techniques often involve parameters that control the strength and behavior of the sharpening effect. Let us explore these parameters. So, strength parameter in unsharpening masking particularly defines the strength parameter determines the contribution of the high frequency components to the final sharpened image. Higher values result in a stronger sharpening effect. So, we can learn it by this code, Python code. You can learn and we can apply this code by exploring the libraries. First of all you have to import the library, then we have to load the image, then again convert that image to grayscale. Again we are converting here by CVT color function which already discussed in previous lecture. So, this is very useful function for conversion of any particular image. Here we are converting BGR image to grayscale image. After that we have to apply Gaussian smoothing to create a blurred version of that image. That blurred image is defining using Gaussian blur function which is giving the grayscale image with the values. So, adjust the strength parameter to control the sharpening effect and we can get that sharpened image with some weighted value before that we have to understand what is the grayscale image and blurred image with sufficient knowledge of that particular value. So, in sharpened image we have some weighted value, or we have to add some value to identify that particular image. After that we have to display the original and sharpened images by using image show, which will justify which is the original image or grayscale image or sharpened image. So, this is the overall sharpened image description for this particular technique. You have to apply all the above codes on your system and check whether the code is working or not. After that we are going to conclude this topic with the particular experimentation work. So, before that we can say that applying image smoothing and sharpening techniques are essential steps in image processing and computer vision tasks. So, in each technique we have seen that it serves a specific purpose and offers distinct advantages. Like image smoothing, basically image smoothing, it provides list of functions in this like noise reduction. Smoothing techniques like Gaussian blur and median filter help to reduce noise in an image, making it more suitable for subsequent analysis. Second one is age preservance. Some smoothing filters like bilateral filtering preserve edges while reducing noise, making them useful for tasks where age information is critical. Third one is pre-processing, which is very essential task during the image experimentation. In image experiment we need to pre-process the image because our image is in a raw data. If we want to pre-process, then we have to increase the efficiency. If our image is pre-processed, then we can say that image is going to be enhanced with some particular quality. So, pre-processing means smoothing is often used as a pre-processing step for various computer vision algorithms to enhance image quality and simplify subsequent computations. And the next one is object detection and segmentation. We discussed in previous lecture also that object detection and segmentation is a very crucial task which is very much required in the real world, because object detection and segmentation provide any image. If we want to extract any object related information, or if we want to extract the information from that particular image, and if that image is not having sufficient quality, so we have to improve that image. For that we need these techniques, object detection and segmentation. So, in this technique smoothing can aid in enhancing object detection and segmentation tasks by reducing irrelevant details and noise. That irrelevant details we can say like background, and if we want to extract that particular object, so we have to remove that particular background. According to that we can calculate which one is the better. So, in image sharpening we can say that enhances image details by sharpening the techniques. So, in sharpening technique that enhances the edges and fine details in an image, making it visually clear and more appealing, that improving local contrast also. In this, by emphasizing the differences in intensity values at edges, and sharpening techniques improve local contrast and make the image stand out. Next one is feature extraction. In this, sharpening can be useful in feature extraction tasks as it enhances salient feature in the image. Some other feature like physiological feature which are going to be explained, that these features are basically defining the external, or we can say external feature of that particular image. So, it is basically making them easier to identify and analyze. Next is restoring blurred images. In some cases sharpening can help to recover lost details from blurred images, although it may not fully restore the original quality of that particular image, but somewhat it is going to enhance the image quality. So, applying image smoothing and sharpening techniques, which is a very crucial part of image processing workflows. Smoothing helps in noise reduction and pre-processing as we discussed previously also, while sharpening enhances the visibility of image features and details, the choice of a particular technique that depends on the specific task requirement and the characteristics of the input image. If our input image is related to signal, then we can say it is going to some other library function. If our input is related to image, then we can say some other library function. It depends on the input images. So, it is essential to strike a balance between noise reduction and detail preservation while ensuring that the image remains suitable for the intended analysis or visualization. Additionally, it is common to apply these techniques as a part of a larger image enhancement pipeline to improve the overall quality and suitability of images for computer vision and other image related applications. There are some of the outcomes of that particular topic. The outcomes of applying image smoothing and sharpening techniques to an image dependent on the specific methods used, the parameters chosen and the characteristics of the input image. Here are some general outcomes for each set of techniques. First is image smoothing outcomes, which also very important for the image quality enhancement. In this we have to identify first noise reduction, that is smoothing techniques effectively reduces random noise in the image, resulting in a cleaner and less grainy appearance. Second one is blur. Image smoothing causes blurring, which can reduce fine details and make the image appear less sharp. Next one is edge preservation. Some smoothing methods such as bilateral filtering that preserves edges while reducing noise, leading to smoother regions without excessively blurring the edges. Then next is smoothing strength. The strength of smoothing can be controlled by adjusting the parameters of the smoothing filter. Stronger smoothing will remove more noise but may also blur the image more. Image sharpening outcomes like first is enhanced details, which is very crucial for image quality. That sharpening techniques emphasize edges and fine details in the image, making it visible clearer and more defined. Next is increased contrast. Image sharpening increases local contrast, making the edges more distinguishable from the background, which is very crucial. Unless we distinguish that which one is the background and which one is the object, we cannot use the object detection technique. Then artifact amplification. In this, sharpening may amplify noise or introduce artifacts, especially if the sharpening strength is too high. Then the sensitivity to noise. In this, sharpening can also enhance noise in the image, which may be undesirable, or we can say in low quality or noisy images. Then combined outcomes, we can say when using both smoothing and sharpening together, the outcomes depends on the order of application and the specific methods chosen. Generally, smoothing followed by sharpening can help to reduce noise first and then enhance the image details and edges. Sharpening followed by smoothing may emphasize details first, but the subsequent smoothing can mitigate any amplified noise or artifacts. It is essential to strike a balance between noise reduction and detail preservation while avoiding excessive blurring or sharpening, as these can lead to unrealistic or undesirable results. Often, image enhancement pipelines involves a combination of pre-processing or smoothing and enhancement as sharpening, so that tailor to the specific task or application requirements. So, in conclusion, image smoothing and sharpening techniques are powerful tools in image processing that can significantly impact the visual appearance and usability of images. Understanding their effects and selecting appropriate methods and parameters are essential for achieving the desired outcomes in various computer vision tasks and image related applications. Thank you.